Hello students, today we begin our lesson on mensuration. This is part 1 and in this session we will focus only on two-dimensional or 2D figures. By the end of this lesson, you will clearly understand formulas, solve examples and real-life applications of 2D mensuration. Mensuration is the branch of mathematics that deals with measurement. The word comes from measure. It helps us calculate perimeter, area, and volume of geometric figures. Two-dimensional shapes, or 2D, are flat. They have only length and breadth. Three-dimensional shapes, or 3D, have depth in addition.
Sir, may I ask a question? What is the simplest way to remember whether a figure is 2D or 3D?
Good question. If you can draw the figure fully on paper without needing thickness, it is 2D. If the figure requires height or thickness, like a ball or box, it is 3D. Before moving to formulas, let's revise the key terms: perimeter, the boundary length of a figure; area, the surface enclosed inside the figure. In 2D mensuration, we mostly work with perimeter and area. Students, until now we studied area and perimeter of 2D shapes. But when we move to 3D figures, two new concepts become very important. First is volume. It simply means the space occupied by a solid object. For example, how much water a jug can hold is its volume. Second is surface area. It is the total covering area of a solid. Think of wrapping a gift box. The paper needed to cover it fully is the surface area. When we talk about surface area of 3D objects, we divide it into two parts. First is the lateral surface area, or LSA. It means the surface area of the sides only, without the top and bottom. For example, if you peel the label of a cold drink can, that curved sheet is the lateral surface area. Second is the total surface area, or TSA. It includes everything, the lateral surface plus the top and bottom. So, TSA is equal to LSA plus top plus bottom. In short, LSA covers the sides, TSA covers the whole figure. Let's start with a rectangle. Suppose length is equal to 10 centimeters and breadth is equal to 5 centimeters. Area is equal to length times breadth is equal to 10 times 5 equals 50 square centimeters. Perimeter is equal to 2 times length plus breadth is equal to 2 times 10 plus 5 is equal to 30 centimeters. This is how area and perimeter formulas work together. A square is a special rectangle with all sides equal. Area is equal to side squared. Perimeter is equal to 4 times side. Example, if side is equal to 6 centimeters, area is equal to 36 square centimeters, perimeter is equal to 24 centimeters. For a circle, area is equal to pi r squared. Circumference is equal to 2 pi r. If radius is equal to 7 centimeters, area is equal to 154 square centimeters approximately, and circumference 44 centimeters. Remember, pi is taken as 22 by 7 or 3.14. Example, if radius is equal to 7 centimeters, area is equal to 154 square centimeters approximately, and circumference 44 centimeters. Remember, pi is taken as 22 by 7 or 3.14. Now, the triangle. Formula for area is equal to 1 by 2 times base times height.
Sir, what if the height is not given?
Trapezium is a quadrilateral with one pair of parallel sides. Formula: area is equal to 1 by 2 times sum of parallel sides times height. Example: base is equal to 10 centimeters, height is equal to 5 centimeters, area is equal to 1 by 2 times 10 times 5 equals 25 cm superscript 2. Perimeter is the sum of all sides. If sides are 6, 8 and 10 centimeters perimeter is equal to 24 centimeters. A rhombus has all sides equal but angles are not necessarily 90 degrees. Formula: area is equal to 1 by 2 times d1 times d2. Sometimes we need the area of a sector. Formula: area is equal to theta by 360 times pi r squared. Example: radius is equal to 6 centimeters, angle is equal to 60 degrees. Area is equal to 16 times pi times 3618.8 square centimeters. To understand better, use cardboard cutouts of shapes, graph papers, or digital animations. Practice with worksheets where different shapes are mixed. So students, this was part 1 of mensuration, where we focused on 2D figures like rectangle, square, triangle, circle, trapezium, and rhombus. In part 2, we will learn about 3D shapes and their applications. Jai Hind.